Hey, 6th grade, welcome to today's video tutorial. Today we're moving on to 3.4. Chapter 3 is still algebraic expressions and properties. And section 4 is right here, the distributive property. Okay, for our learning target, it is I can use the distributive property to simplify algebraic expressions. I can use the distributive property to simplify algebraic expressions. Okay, so for our key idea then today, we'll be talking about, yeah, you guessed it, the distributive property. And when you hear distributive, hopefully you hear that root word of distribute. Okay, when you distribute something, you hand something out to everybody. Okay, and that's kind of what the distributive property does. It actually takes whatever is on the outside of your parentheses and distributes it to whatever on the inside of your parentheses. In words, it says to multiply a sum or difference by a number, multiply each number in the sum or difference by the number outside the parentheses, and then evaluate. So here, this means 3 times 7 plus, they get that from the addition sign here, 3 times 2. Okay, and then you'd figure out the answer from that. Algebra looks similar to that, and you can also see here the distributive property is shown using, what's this called? Angry Birds or something like that, where they had the birds that you launch at the pigs, kind of that fun game. But same thing, red bird times green pig or whatever that is, and then red bird plus red bird times bluebird. So that's how the distributive property works. And the most useful way that I think the distributive property is used is when you use it for mental math. Okay, that, if you saw this problem right here, 8 times 53, that might be a little bit tricky to do using mental math. So let's try using the distributive property to do so. The way I'm going to do that is I'm going to break down this number into two numbers added together. So I'm going to change this into 8 times. Instead of writing times, I'm going to use the parentheses. That implies multiplication. And I'm going to break down this 53 into 50 plus 3. Okay, real simple. I just broke it apart right here into 50 plus 3. Then I'm going to distribute. I would encourage you to use arrows. That's really helpful to me. I get 8 times 50 plus 8 times 3 as well. Okay, and that's a lot easier for me to do using mental math, right? 8 times 5 is 40, plus the 0 will give me 400, plus 8 times 3 is 24. Add those together for a total of 424. Okay, now I know that a bunch of you could probably do it the old-fashioned way or the conventional way, going like this, 53 times 8, and writing it down that way. But again, that's not the goal here. The goal is that you're able to break this number down and use mental math to be able to figure out this answer. Okay, again, don't try not to do it this way. That's the conventional way. I know you already know how to do it that way. Okay. Show that you're using the distributive property. Show your work similar to this. Okay, let's see another example. It says use the distributive property to find a half times 2 3/4. Okay, again, if you were using just the conventional method, you would maybe go like 1/2 times, and then you would change this into an improper fraction. So 2 times 4 is 8, plus 3 is 11/4, and then multiply across, and so on and so forth. Again, we want to use this in a different way. So we're going to take our first number and we're going to multiply it by the second number, but we're going to break this down into two numbers that are a little bit easier to think about. So we're going to break 2 3/4 down just right here, just similar to what we did the first number. So we're going to break it down into 2 plus 3/4. Okay. Now it becomes a little bit easier. I've got a half times 1, so a half times 1, or excuse me, 2. Half times 2, I got a little bit ahead of myself, plus a half times 3/4 as well. Half times 3/4 as well. Okay, well, half times 2, well, half of 2 is 1, and a half times 3/4, we can just multiply across. 1 times 3 is 3, and 2 times 4 is 8. So that would be 3/8. Well, 1 whole plus 3/8 would just give me 1 3/8 for a total there. Okay. Again, distributive property, one of the biggest things, break down the second number into two numbers added together and use arrows to show that. All right, pause the video and try these 6 on your own. Again, please show your work for these. I know you could do them the conventional way, but please do it using the distributive property. It's good practice. All right, number 1, should have gotten 205. Number 2, 171. Number 3, 222. Number 4 is 1. Number 5 is 1 1/20th. And lastly, number 6, we have 1 1/14th. Okay. If you have any questions on any of those, please feel free to let me know, and I can show you how to do them. With example 3, now we're going to use the distributive property to simplify not numerical expressions, but algebraic. So we'll introduce some letters here. All right. So for the first one, use the distributive property to simplify the expression. Okay. I'm taking my outside number and I'm multiplying it by everything on the inside of my parentheses. So I have 4 times n plus 4 times 5. Okay, 4 times n, well, that's just 4n plus 4 times 5, that is 20. Okay, and I cannot combine these two because this one doesn't have an n. These are not like terms. This is as simple as I can get it. Okay, that would be my final answer. That is the expression they're looking for. Okay, very similar to the next one. 12 times 2y would give me a total of 24y. And careful now, they're trying to trick you. Minus, we're subtracting 12 times 3. And 12 times 3 is 36. Again, this one doesn't have a y, so I can't subtract anything here. This is as simple as I can get. 24y minus 36. And finishing it out, this last time here, we have to multiply 9 3 times. Okay, everything inside the parentheses. So first I get 9 times 6, which will give me 54, plus 9 times x would be 9x, plus 9 times 2 would give me 18. All right, so now I look at this and I see that I do have a few like terms that I can combine. I have 54 plus 18. Always take that operation in front of the term. So I've got 54 plus 18. I can combine those two things. That would give me a total of 72. And I have 72 plus 9x. Now I can't combine these because this does not have an x. Remember, you could switch that order, so it could be 9x plus 72. That would be the same thing. Okay? See that I'm almost up on my time limit. So if you would, pause the video and try 7, 8, and 9 for the on your own problems, and I'll be back to check them. All right, for number 7, you should have come up with 7a plus 14. For number 8, you should come up with 3d minus 33. And number 9, you should come up with 56 minus 28d. Again, let me know if you have any questions about that. All right, example 4 is a real life example. It says Jose is X years old. His brother Felipe is 2 years older than Jose. Their aunt Maria is 3 times as old as Felipe, right? And simplify an expression that represents Maria's age in years. Kind of a mouthful there, okay? Well, it starts off and it tells us that Jose is X years old, okay? So here's the description of that person. How can we write that as an expression? Well, that's pretty easy. We just write it as X, okay? When we go to Felipe in the next sentence, it says that he's 2 years older than Jose. So what we need to do to find Felipe's age is we need to take Jose's age, which is X, and we need to add 2. He's 2 years older. Okay? And in the last sentence, it tells us that their aunt is 3 times as old as Felipe. Well, here's Felipe's age. It's X plus 2, and she's 3 times as old as that. So if we were to take 3 times his age, we could write it similar to like one of these distributive property examples. This means 3 times his age, which was X plus 2. Okay, so we can just simplify from there. We can actually distribute our 3 into this expression to figure out our expression in simplest form. Okay, so let me use a different color here. I'll distribute my 3 to the x. 3 times x would give me 3x, and I'm adding right here, and then 3 times 2 would give me 6. So this is as simple as I can get for the expression that represents Maria's age in years, 3x plus 6. Okay. Moving on to a little bit of vocabulary. It says in an algebraic expression, that should be, let me fix this. In an algebraic expression, like terms. This is a very important idea. I would star this if I were you. Like terms are something you will see all the way up until, boy, I would say even Algebra 2. Very important idea. Like terms are terms that have the same variables raised to the same exponents. Lastly, it says constant terms are also like terms. If you remember, constants are just numbers. Most of the time, they're all alone. All right? So in this problem here, if I were looking at my like terms, I would say 5x and 2x are like terms because they have the same variable. They both have x. Okay? It doesn't matter that their coefficients are different. They both have an x, so they're like. And we also have another set of like terms. We have 19 and 2. They are also like terms because they are constants. They're just numbers. All right? So what we can do is we can combine these like terms to make our algebraic expression a little bit more simple. So let's see what that looks like in this example here. It says, combining like terms, simplify each expression. Okay? So I have 3x plus 9 plus 2x minus 5. Looks like quite a bit of mumble jumble here, but just find your like terms. So I've got 3x, and I have another term that has an x, and I'm going to also circle or box the operation in front, so it was plus. So if I have 3 x's, and I add 2 x's to that. Now how many do I have? 5 x's. And then I also have 9, or if you look at it this way, positive 9 minus 5, right? And 9 minus 5 would give me a total of 4, or positive 4. So my expression would be 5x plus 4. This would be in simple, this would be this expression simplified. Okay. Let's try again. On the next one, what are my like terms in this expression, y plus y plus y? Well, they all are like, right? They all have the letter y, so I can add them all. And remember, if there's nothing in front, we assume it's 1, right? So 1y plus 1y plus 1y will give me a total of 3y. And that's as simple as I can get. And lastly, letter C is a bit more to it. A couple steps in this one where first, you see you got the parentheses here. You're going to want to be thinking about distributing, okay, at first. So I have 2 times z, which would give me 2z. And then I'm subtracting 2 times 5y, which would give me a total of 10y. Okay. I haven't done anything with this 7z plus, so I'll just bring this down in my problem. 7z plus 2z minus 10y. Okay. Now I can look for like terms. Well, these two both have a z. I have 7z plus 2z. That would give me 9z. And I'm subtracting 10y. Well, those are not like terms. I can't subtract y's from z's, so I'll just write it as minus 10y. You can't forget about it because that would totally change the problem. But I'll write it right next to 9z to finish my expression. Okay, so maybe it's the first time that you've seen problems like these, so don't be too intimidated by them. We'll get lots of practice with them. So pause the video and try 11 and 12 on your own, please. All right, to wrap things up today, we've got these two like terms. So 3z minus 1z would be 2z, and 8 is not like that. So I can't do anything with the 8 plus. I'll just bring it down. 8 plus, and 3z minus z is 2z. So 8 plus 2z for 11. And the next one, distribute first. So that would give you 3 times b is 3b plus 3 times 5 is 15. We haven't done anything with this information yet. Bring it down in our problem, plus b plus 2. Now look at like terms. I've got 3b and b that are like. 3b plus 1b will give me 4b, plus 15 and 2 are like terms. So 15 plus 2 would give me 17. And there you have it. All right, so this wraps up 3.4, the distributive property. Get some practice in with these, and let me know if you have any questions. Until next time, we will talk to you later.